Beam is defined as a structural member which is used to bear different loads along their length to the supports with the objective of withstand vertical loads, shear forces, and bending moments. The beams usually have three different types of support. Hanging support that is capable of resisting force acting in any direction of the plane. In general, the reaction at such a support made to have components, one in horizontal and other in vertical direction. The second one is the roller support that is capable of resisting a force in only one specific line or action. The roller can resist only a vertical force or a force normal to the plane on which roller moves. The last one is fixed support that is capable of resisting force in any direction and is also capable of resisting a couple or a moment. A system of three forces can exist at such a support: two components, horizontal and vertical, and the moment, used in cantilever beams.
We are looking at some examples of how the forces in the beams will be applied. Remember that any deformation will suffer consequences in the support.
This is the first example to resolve of beam of concentrate loads. The first step is to put the reactions of the two supports that we have, hang and roller support. The second step is to get the equilibrium of x and y axis. The x force is equal 0 because we don't have any horizontal force, and y-axis is the sum of all the vertical forces with their corresponding sign. AY plus BY plus 50 minus 80 minus 60 equals 0. To know known forces, we need to get the moment using a respective support of guide to the distance with their corresponding sign. The moment is By multiplied by 4.75 minus 80 multiplied by 6.75 minus 60 multiplied by 2.75 plus 50 equals 0. Then we got 140 plus 165 minus 50, amount 4.75 equal 137.89. Then we got the AY with the BY that we got, and it's 140 minus 187.89 equal minus 47.89. Here we have a problem of a cantilever beam. First, we need to put the reactions of the fixed support. Then we get the equilibrium of the x-axis and the y-axis. The x-axis is equal 0 because we don't have any horizontal force. And y-axis is the sum of all the vertical forces with the corresponding sign. AY minus 50 minus 10 equals 0. And we get 60 in the AY force. And for the last one, we get a momentum. That is cantilever moment minus 50 multiplied by 2 minus 10 multiplied by 5 equals 0. That gets 100 plus 50. That the result is 150.
We will start to remove the centroid from the beam. It is taking multiplying the weight of the load by the length of the beam, resulting 50 times 75. We will put the address, and it is very important, remember. We will start to take out y. AY plus BY minus 75 equal to 0. AY equals 75 minus by. Now, we will take the moment to remove by. The moment is equal to minus 75 by 2.5 plus by 5. Returns 187.5 plus 5 by. Now 5 by equals 187.5. Clearing by results is 37.5. With this result, we can do the above operation and get AY clear AY that is equal to 75 minus 37.5, resulting in 37.5. Now we will make the graph of cutting and moments. The first is the cutting. We locate at 0 point and climb 37.5. From there we were down 75 to reach minus 37.5. And at the last point it goes back up to 37.5, again being 0. We move to the graph of moments where we will extract the area of the triangle with base by 8 over 2, 2.5 multiplied by 37.5 divided by 2, giving us a result 46.85. That point is the maximum. Then result in the graph of mountains as a parabola with its maximum point.
We have a bin with a cross-section to which we apply an uniformly distribute load that is called W load. It is simply supported. If we imagine how the bin is deformed, it will be something like that. From the deformation, we can identify that the fibers above are in compression, and those below are working at tension. There is an axis that does not stretch or shrink and is called the neutral axis, remains the same length. We have a formula that defines the effort. We will call it sigma, and this is equal to the moment multiplied by a distance z divided by the moment of inertia. This moment coincides with the centroid. M is equal to bending moment. C is equal to the distance from the neutral or centroid axis to the extreme fiber. X is equal to the moment of inertia of the cross-section. This is called the formula of flexion. The units that we are used are pascals or kilopascals. How is it represented? This bin will have a maximum moment at the center and our diagram will be parabolic. At the center we have a distribution of stress. As there is no deformation in the neutral axis, there is no deformation and the stress is 0. And as I go away, it starts to grow in a linear way up to a maximum. And this is the sigma distribution and the neutral axis down in tension. And this is called the distribution of normal effort or effort in bins.
This is an example of what reaction each support has. And this is another example of how the load causes the cantilever beam to deform. As a team, we believe that having good calculation of strain and good identification of the burdens will help us avoid problems in the future that can cause us a whole career or worse, a life owing to our own. Thank you.